Okay, we're starting again at probability assignment 2, question 20. Okay, so we got this table below and gives the numbers of suicides estimated in the US for recent year by age, race, black or white, and sex. We are interested in possible relationships between age, race, and sex. We will let suicide victims be our population. Okay, so we've got all of this and we've got some things missing over here, right? So they want us to fill this in. I don't know that I'll do every single one, but basically if we take that number, the 22,000, I go straight for the totals, and to that 22,050, and I minus everything in this row, 13,610, and then minus the second one, 3,365, minus the next one, which is 215, then it'll be 4,860. we put that there. Same thing, we go across, take that number minus all of these, we'll figure out what this is, take that number minus all of these, figure out that, take that number minus all of those, get this number, and then this one is all missing, so we take this total minus all of that, and we're gonna get this. Take this total minus all of this, you get that, and just keep going. When it comes to this one, if we take this total minus all of these, we're gonna figure out what that total is. Okay, right? The 29,760 minus the 18,780 minus 4,650 minus 310 should come out to 6,020. Again, your numbers will be different, but these numbers should be the same because they don't have any red. So that means they don't change. Find the probability that a randomly selected individual was a white male. We've got white male. Randomly selected, that means it can be any one of these men. So it's 22,050. 22,050 out of how many? Out of the total of everybody, added all these numbers added together, comes out to 29,760. So fraction would be 22,050 over 29,760. And probably later on, like I said, from the other students, sounds like you're gonna have to get to the reduced fraction, but right now it's going in without reducing it. Find the probability that a randomly selected individual was a black female. Black female, we've got any one of these 330 black females out of 29,760. Okay, so we've got that. Find the probability that a randomly selected individual was black. Let's see, so it could be a black female or a black male. So let's go to the total of black female and the black male. 1,670 plus 4,930. You add these two together, you're going to get, for me, I got 2,000. And so 2,000 over the total to 29,760. And then the next one is find the probability that a randomly selected individual was male. Do not include the other males. Do not include the other male individuals. Okay, so it can be a black male, or it could be, I'm going to just bring my paper over here. Okay, so we've got the black male and the white male. Okay, so my black males are, the total is 1,670. Then I've got the white males, which is 22,050, and you add those two together, we got 23,720. And again, we're going to put that over the total 29,760. Okay, so we got 23,720 over 29,760. Last one. Out of the individuals over age 64, find the probability that a randomly selected individual was a black or white male. Okay, so we're just looking at those who are 64. The black male, 140. White male, 4,860. Add those two because those are just the probability of those two males in this category over 64. And I've got 4,860 plus 140, right? 140 plus the 4,860, and that comes out to 5,000. And that 5,000 is going to go over the total of anybody that could be over 64. The total is 6,020. Right? 6,020 is the total for anybody over 64. So it's 5,000 over 6,020. Again, later, just keep thinking. We're probably going to have to do reduced fractions.
Destiny.
Okay, so we've got question 21. The following table identifies a group of children by one of 4 hair colors and by the type of color. Again, we're going to fill in these charts. Take that total, minus this, minus that, minus that. You should come up with this. Take this and you add it to this. You should get that 100. Take this and this together. Right, so take this and you minus that, you should get this. And again, the totals, just always focus on the totals. Take this total minus that, you should get that. And just kind of work your way until you finish all of those numbers. What is the probability that a randomly selected child will have wavy hair? Okay, randomly selected child, wavy hair. That means it could be any child. Any child that has wavy hair. Here we got wavy hair. Any child, total 42. Chances are 42 out of 216. What is the probability that a randomly selected child will have either brown or blonde hair? Anybody could have blonde or brown. So then we got brown, the total of that is 100. Total of blonde is 18. Add that together, you got 118 out of the total 216. Okay, part D. What is the probability that a randomly selected child will have wavy brown hair? Wavy brown hair. We've got wavy and we've got brown. And so it's 20, right? We've got 20. Well, that could be wavy or brown out of 216. Okay, so we got 20 out of 216. We've got, what is the probability that a randomly selected child will have red hair, given that he has straight hair? So we're gonna look at the straight hair. We've got straight here. And what is the probability that it could be red? I think it said red. Right, yeah, red. Okay, so we got red and we got straight. There's 14 chances that it could be red and straight out of all the people that have straight hair. So it's 14 out of 100, and this is 174. So the total of people that could have red hair is 174. So it's 14 out of 174. If B is the event of a child having brown hair, find the probability of the complement of B. The complement would be the opposite of a child having brown hair. Okay, so we got who has brown hair? 100. 100 people have brown hair. Of how many people? What is the total amount? 216. Right? There's 216. So the complement, if 100 have brown, how many don't have brown? Well, there's 116 more, because 100, right, plus, or if I were to do this, right, 216 minus 100, what's left? 116 don't have brown hair. Right? 116 don't have brown hair. So it's 116 out of 216 that don't have brown hair. Let's see what else we got. Okay. If B is the event of a child having brown hair, what does the complement of B represent? The complement of B would be the event of a child not having brown hair. Alright, let's see about this here. Okay, this tree diagram shows, oh, we're on question 22, sorry. This tree diagram shows the tossing of an unfair coin followed by drawing one bead from a cup containing 7 red, 3 yellow, and 2 blue beads for the coin, and the possibility of heads equals 1/3, and the possibility of tails is 2/3, where H is heads and T is tails. Find the possibility of tossing a head on the coin and a red bead. Okay, so this one here is taking, let me see if I can get this. How many reds do we have? We have 7 red beads out of how many? 7, 10 plus 3 is 10 plus 2 is 12. So there's 12 possible choices when it comes to the colors, right, of the beads. There's 12 beads. So the red is 7 over 12. Alright. And then the heads, the probability of having a heads is 1/3. Okay, I'm sorry, it shouldn't be a plus, it should be a times. 1/3. Okay, so when we times that together, we got 7 over 36. Okay, so what is the probability of tossing a head on a coin and a red bead? You have to take those, all the possibilities of it being red and of it being heads, and times that together, and that's how you're going to get the answer. Alrighty, next one. 23. A box of cookies contains 3 chocolate, 7 butter cookies. Miguel randomly selects a cookie and eats it. Then he randomly selects another cookie and eats it. How many cookies did he eat? So we're going to draw this table. You're going to see that I got it wrong because I was totally guessing at the time. Let's take a look at this. Okay, I put the correct answers for mine here. So basically, first chance, there are 7 butter cookies, right? Okay, so let me see if I can get this right. We have 7 butter cookies plus the 3, so that's 7 out of 10, and then there's 3 out of 10 for the chocolate. So we got 7, 10 because the B is for butter cookies, right? 7 out of 10, 3 out of 10 for the chocolate. The second cookie that we could choose from. How many butter cookies are left of all the 10? Now we've taken 1 away, so now there's only 9 left. How many butter cookies are left? There's 6 more butter cookies left, so it's 6 out of 9. How many chocolate cookies are left? Well, if we didn't take any yet, if we didn't take any chocolate cookies left, then it'd be 3 cookies. There'd still be 3 chocolate cookies. And there's only 9 choices left, so it's 3 out of 9. All 3 chocolate cookies are all still there. Okay, on this side, we've got how many chocolate cookies? 3 out of 10. Okay, so now you've taken 1. We've got 1 chocolate cookie here. What is the probability for the others? Okay, well, for the butter cookie, we haven't taken any, and there were 7 to begin with, and there's only 9 cookies left, so we still have 7 out of 9 chances to get the second cookie. All 7 butter cookies are still there. Okay, on this side, this is not 1/6, it's 2/9, because we've already taken 1 of the chocolates. Now there's only 2 left, but there's still 9 chances. So 2 out of the 9, so only 2 left with still 9 chances of basically 9 cookies left. So there's 2 left that could be chocolate. Okay, so that's basically it for that. Again, don't look at what I have. If I crossed it out, or maybe some of I didn't cross it out. Cross that one out. Cross that one out. This is what this is. Yeah. Cross this one out. Read that. That's what it would be for me. It might be different for you, but basically you get the idea. Depending on what your numbers up here says. Mine says 3 chocolate and 7 butter. Yours is probably going to be different. Okay, next one. The probabilities for the second cookie selection are independent of the first selection. Are the probabilities for the flavor of the second cookie that Miguel selects independent of his first selection? The answer is the probabilities for the second cookie selection are dependent on the first selection. The probability of a chocolate cookie being selected second is dependent on whether a chocolate or butter cookie was selected first. Okay, does that make sense? Okay, part C. For each complete path through the tree, write the event it represents and find the probabilities. Enter your possibilities as fractions. Okay. what is the possibility of it being butter butter? Okay, so here we go. What is the possibilities of it being BB? So we follow this line here, BB, and we times this together, the 7 times the 6 and the 10 times the 9. Okay, 7 tenths times 6 ninths equals 42 over 90. Break that down. We got 21 over 45. See, I divided both sides by 2. Okay, yeah, so that's reduced. Probably if you put the 42 over 90, that would have been fine. Okay, so you do the same thing when it comes to the B and C. B and C, so you take the B 7 tenths times whatever this number is supposed to be for me. It would be 7 tenths times 3 ninths, right? 21 over 90. Divide both sides by 3. Oh, sorry. We would get 7 over 30, I believe. Okay, is that what I got? Yep. Okay, 7 over 30. If I did CB, C and then B, it'd be 3 tenths times 7 ninths. It would come out to exactly the same thing, 7 over 30. Then it would be 3 tenths times 2 ninths. Divide by 3. Got 2 over 30. Wait, no. 2 over 45. No, 3. 2 over 30. That means it can go down further. 1 over 15. Alright. So let's see. I got 1 over 15. Yeah, I broke it down to 1/15. I think, honestly, if you had put just the first number, the 6 over 90, he probably would have taken it. But I just had reduced it in this particular part. So that's how you get that. And then let S be the event that both cookies selected were the same flavor. Find the possibility of S, which is, let me see here. Okay. So, okay, so this one here was the BB, and this one here was the CC. Okay, so if we just take the two that were with 90, and then we would take that and we would add it together. So 42 over 90 and 6. Let's just, okay, I'm dying my finger. Okay, sorry, 42 over 90 plus the 6 over 90 equals 48 over 90. And if I were to divide that by 2 to break it down, we've got 24 over 45. Both of these answers are correct, though. Just how far do you want to reduce it? Okay, so again, in the state that they both had the same denominator, which is 90, you could add whatever's in this box and this box together because they both have the same flavor. Okay, so it would be 48 over 90, or in my case, when I break it down, 24 over 45. Alright, let's get this cleaned up. Okay, so part E, let T be the event that both cookies selected were different flavors. Find the probability of 2, we're using the 2 different methods. Okay, so there's these 2 that had different flavors, the butter cookie and the chocolate and the butter cookie. So we take those 2, they have the same denominator, 7 over 30, right? So we can add those 2 together. And we come up with 14 over 30. And that would probably be fine if you just left it like that, or divide it by 2, and I've got 7 over 15. And that would be fine too in the reduced terms. Okay, so I've got it under 7 over 15. Could have had it at 14 over 30. Let U be the event, this is F, let U be the event that the second cookie selected is a butter cookie. I don't really understand this, to be honest, but I do know that the answer is this here, the butter cookie. It's 7 over 10, 7/10, and that's something I need to ask him about. I just don't understand that, how that would have to do with the second cookie selected is a butter cookie. Okay, so that's just something to look into. We're on problem the last one. How about we cover it in this video? Okay, so we've got, let me bring this down. Okay, number 24. Suppose the percent of licensed U.S. drivers from a recent year that are female is 49.10%. Of the females, 5.49% are age 19 and under. 80.73% are age 20 to 64, and 13.78% are aged 65 or over. Of the licensed U.S. male drivers, 5.03% are age 19 and under, and then 81.67% are age 20 to 64, and 13.3% are age 65 or over. Okay, so I thought you could just put these numbers in there, but no, you can't. But we can start with this. What is the total amount of female? Okay, so the used drivers from a recent year that are female is 49.10%. So we know that the total of female drivers are 49.10%. We don't know what the male is, but from that, knowing what the female is, we can just minus the 49.10%, right? And if you were to calculate that, or if you were just to go 1 minus 0.4910, either way you decide to do it, you're gonna come up with 50.90% or 0.5090. But because they want it in percent and not in decimal, you would move that. Okay, so we put 50.90%, but we still don't know what any of these are. These totals here, of the females, of that 49.10%, 5.49% of that total is 19 and under. So the only way, we can't put 5.49%, that would be wrong. We have to find out what that would be. What percentage is that from this? Okay, so let's do this. 49.10 times 5.49, and we would get 269, right? See, I get confused when I do it this way. So honestly, I turn everything into a decimal and then I put it back into a percentage. Okay, so the way I did it, oh, sorry. The way I do it is I take the 0.49, right, moving the decimal over 2 times to turn a percentage into a decimal, times, if I take the 5, so move that over, it'd be 0.0549, right? Move the decimal 2 times over, there would be a 0. Then we got that. Okay, so it's 0.0269. Now I move it 2 times back, and I've got it right there. 2.69, but that 5 bumps it up, so it's 2.70. So that's how I got the 2.70. Okay, doing it again. 4.4910. Turning that into a decimal. I'm going to times that by the percentage for the 20 to 64. 80.73 are age 20 to 64. So I move that decimal 2 over, and I've got 0.8073. And I've got 0.3963. I move that decimal 2 over, and I've got 39.63. Interesting. Why did that not round up to a 4? Let me look at that again. 0.4910 times 0.8073. Yep. I don't know why I didn't round off to a 4. Very curious. Okay. Then 49.4910 times, what is the 65 and over for female? Right here we got 13.78, our age 65 or over. So times that by 0.1378, and we got 0.067, and that would bump that up to a 7. So if I move that right, I just want to make sure that I'm being clear. 0.676. If I want to turn that into, and then a 5. If I want to turn that from a decimal to a percent and move that 2 over, so we got 6.7, and we're just doing 2, so that would turn to 7, and that would be the percentage. Okay. All right. So we do the same thing for the male. It would be point for this here, 0.5090 times, and then what is the male? Is 0.0503, right, for the age 19 and under, and we get 0.0256. Moving that decimal over, I've got 256%. Nothing rounding it off. Oh, jeez. Yep, there we go. 2.56. Okay, do the same thing for all of these. Yeah, just match it up. The 81.67% times the times this, the 50.90% times the 50.90% times that 13.3 will give you what you need for that, and then just add them up, add those up, and it should equal 100 going across. Okay, here's what I got wrong for number C. I don't know, it supposedly I'm not really sure if that was corrected or not when I typed it in, so I will have to go over that in class. I'm not positive what happened there. Driver is age 65 or over and female. Okay, driver is 65 or over and a female, and we have if we're doing a decimal, yeah, it would be that one. She's female, 65 and over, so it'd be 0.0677 if we're turning it from a percent to a decimal. I don't remember why we're putting round your answers to 2 decimal places. No, that's just for this. I don't know. It just seems that everything has to turn into a decimal. So 0.0677, that's the one. In words, explain the difference between the probabilities in part C and D. And the answer is the probability is in part C is using only the group of females as the sample space, while the probability in part D uses both males and females as the sample space. What is the probability that the driver is age 65 or over? And it's this. There's 65 or over. What is the driver? Is 13.54% of the total drivers that are 65 and over, right? So it'd be 0.1354. Turning that percentage into a decimal, it'd be 0.1354. Okay. And then, are being age 65 or over and being female mutually exclusive events? How do you know? The answer is the events are not mutually exclusive because a person can be female and over the age of 65. Okay, so that's it. I'd have to go over that one again, figure out what happened. I know I got that right on the next assignment, so I'll take a look. But yep, that's it. That's it for probability assignment 2.